All right, I apologize, y'all. Now I'm working. Medium rare. I can't go rare on it though. Can't go rare. So it depends on. Got 15 minutes, but extreme value theorem is pretty easy. You will probably be doing some. Oh. When y'all see this theorem, you're going to go, as I do with most theorems in calculus, well, that's pretty self-explanatory. Like you probably already assumed this. But the extreme value theorem says, if your function is continuous, and of course, every piece of this definition matters, and they will test you on that as you have seen. So continuous is important here. So if it is continuous on, why? Because my grade is bad. Don't worry about your grade right now. I keep telling y'all that. I wish y'all couldn't even see your grade until the end of the 9 weeks. I don't think we're not used to the curve at the end of the 9 weeks. Well, there was a curve on the test, but yeah. If F is don't be mad. Please don't be mad. On a closed interval, what does a closed interval mean? I will say, it's right. It's restrictive. Okay. It's not. I'm not saying x cubed and it being the whole cubic. I would say x cubed on the interval from 1 to 5 or something like that. Okay. So it's a closed interval, and we'll even say a closed interval AB. Then F must have a max and a minimum on that interval. Well, right? Because it has endpoints. That's self-explanatory, right? I told you. Closed domain, obviously. Right. Okay. Right. So along these same lines, let's just talk for just a minute. How do you find a max or a min? And think in terms of calculus.
You go on the calculator and you do the thing where you put 2 points on there. And
think in terms of calculus.
You do a limit?
Close. We're getting there.
A limit?
The derivative. When the derivative equals what?
That's all it is.
You're right. It's all, if you don't know the answer, say derivative. It's probably right. So these happen when the derivative equals 0, right? I'm finding those points. So what I'm going to do to find these critical points, I'm going to set the derivative equal to 0. The difference here, I'm on a closed interval, so I need, and they're going to ask me, you're going to be given an equation, find the maxes and mins of the equation, tell whether they're absolute or relative. To find that, we're going to do a sign analysis, and we've got to figure out which point's higher, which point's lower, when it's increasing, when it's decreasing. It's easier for me to show you with an example, but let me just say, always remember to check the endpoints. And the reason we check the endpoints is because the endpoints might be my max or my min. Okay? Quite possibly. So let's do an example. Dylan, stop being mad or sad or upset. I even fed you cake. I know. Let me see what I can figure out for y'all to do about that test. Huh? Yeah. I might see. I'm not making any promises because I don't know how today's going to go. But I might see what I can come up with y'all to earn some credit back on the test. Just no promises yet. I know.
No, you can't go over 100, Allison. But it already is.
It already is.
If on another test, I just word it.
Can you get points to? Yeah. Well. All right. Let me show you an example. Let me show you an example first of a graph and then an equation, and then I'll be done. I promise. Let's look. Let's look at number 8 because it's a little bit different. So the directions for this say, identify each x value at which any absolute extreme value occur and explain how this is consistent with the extreme value theorem. So I have this graph that does this. And this is A, this is B, and this is C. Huh? So it's asking you, what are the absolute extreme values, absolute max and mins, or where they occur? And how does this line up? Well, in this case, go back to that definition of extreme value theorem. In order to have that extreme value, what's the stipulation? Is it continuous? No. It's not continuous, so this would have none. I would say none, no extremes here because the function's not continuous, which tells me that I can't use extreme value theorem to find an extreme max or min, or an absolute max or min. Now, if you had something like number 5, where it is a continuous function, it looks something like this. Here's A. Here's A. Here's B, C, D, or something like that. Extreme values here. So I would, right. And here I could say that because it's continuous and it's a closed interval. So I could name those extreme values. So it's really easy with a graph.
Now, what about this, like, that's one of the endpoints?
It would. Yes. It would. None. It doesn't satisfy extreme value theorem.
To make sure it's continuous, that means
no holes. It is. And so, and the limits are the same from both sides, and the function value is the same. Good job. See? Correct. We can't call them extreme values because it's not continuous. C and D. Yeah. C and D. Yeah. Lowest. That's okay. That's all right. I'm sorry. I whipped through that because it was kind of fast. Y'all do not be ugly. Let's look at 14 together. I only have 5 minutes. Don't we get out at 9:55? Helen, you better be nice. Are you being, Lizzie, is he being ugly to you?
Because of my grade.
All right. Directions. Use the candidates test. Now this says candidates test.
Wait 1 second. The lowest grade was like a 50 something, so nothing mine's bad. That means Van got like a 30.
Stop. Okay. The candidate's test means find the possibilities and test them. That makes sense, right? A candidate's test, what's a possibility? Who's a candidate? And then C, so it says use the candidate's test to find the extreme values of the function on the interval and where they occur. By the way, sometimes you have where the derivative equals 0, but it's not a max or a min. Those are what we call stationary points. Do you know why? But you're right. Remember when we were doing particle motion? When the derivative equals 0, we said it could change direction. Well, maybe not. Maybe it just took a rest, right? So this is when the derivative is 0, but it's not a max or a min. My particle is just at rest. Kind of, yeah. That never goes away. All right, so here, to use this test to find these critical values, to find my maxes and mins, my extremes, without graphing and using my calculator. This would be a non-calculator problem. What I want to do is I want to find the derivative first, because I know that anywhere the derivative is 0, those are possibilities, right?
All right.
Okay.
I don't have to do it.
All right, do it.
All right, so you do, and then we do change that, so you negative 2x.
That's exactly right.
Yeah. Yeah, you saw that. I got it.
If you like steps, here's step 1, find the derivative. Set it equal to 0 and solve.
So that stipulation,
Those are my endpoints. That's the closed interval, yes. In between -2 and 3, yes.
Are you going to solve for x?
Yes. So where is my derivative 0? Because those are the places that are going to be my candidates. Those are the places where it may or may not be a max or a min. This should feel very familiar to you. We've done this, right? Remember, we even did that. Okay. All right, so how do you solve that? Well, I'm going to use the 0 product property. There's no way to make this 0. What? You could, yeah. But this piece is never going to be 0. Do we all agree? There's nothing I can plug in for x to make that be 0. That's why we have an asymptote at 0 on, right? Okay, right. All right, but this one could be 0. And if I multiply two things together to get 0, one or both of them must be 0. So I'm going to say -2x is 0 when x is 0. Would that make sense to you? That is the only time that I can see that function ever being 0, or that derivative ever being 0. So now I'm going to set up a sign test, okay? And I'm going to use a sign analysis chart to do this. Sign analysis. Do not forget your endpoints. Y'all, the bell's going to catch us. I'm sorry. Just let me finish this one. I tell Coach Hendricks it was my fault. Endpoints, -2 and 3. And I'm going to put the 0 on here. Okay. This is going to be what my derivative is doing, but it's going to tell me what my function is doing. Because remember, when the derivative is positive, my function is increasing. When my derivative is negative, my function is decreasing. It's going to tell me if this point is stationary, max, or min. And then I'm going to check and see which one is higher or lower than the others. So to do that, pick a point in between here. 1, -1. If I plug that into the derivative, so let's think k prime of -1, I'm going to have e to the first, or negative first, right, because that negative's out there, times, I'm going to have a negative times a negative, which is going to give me a positive. So this is going to be positive. You don't have to work it all the way out. You don't have to find that whole value. I just need to know, will it be positive or negative at that point? Yes? Okay. Same thing over here. If this is a positive one, is my derivative positive or negative? It's negative. It is negative. So that means my function is increasing and decreasing.
So e to the negative 1 times 2 is positive.
Well, this is negative 2. But yes, this will be positive because this is 1 over e times 2. This is a positive times a positive, which would give you a positive. Okay? Now, I'm not sure. I know that x equals 0 is a minimum, as a maximum, because I'm increasing and then decreasing, but I don't know if it's absolute or not. So here's where I have to check, and you have to check every single point. So your last step is check endpoints and potential points. Because I need to know which one has the absolute biggest value and the absolute smallest value. So step 3, I plugged into derivative. For step 4, I'm plugging into the function itself. So I'm going to find f of negative 2, or actually it's k. I'm going to find k of negative 2. I'm going to find k of 0. And I'm going to find k of 3. The biggest one will be my max. Absolute, because I can have absolute because I'm closed interval and I'm continuous, right? Yeah. So my biggest value will be my absolute max, and my smallest value will be my absolute min. Because I want to know, it asked me where my absolute values were, so I want to know where my biggest and where my smallest is of the function itself. I don't want, are y'all sure y'all are okay? I mean, I don't care about them standing out there right now, but okay.
We don't do anything. I get down there.
So this would be e to the, keep the negative there, right? Because it's negative 2 squared, which would be e to the, negative 4, or 1 over e to the 4th. For 0, just 1. And for 3, I would have e to the negative 3 squared, which would be 1 over e to the 9th.
So what are you checking?
I'm looking for the biggest value and the smallest value. Smallest, yeah. So this is extreme min, and then the biggest, extreme max, or absolute max, whichever you say. Absolute, yeah.
So then what case is negative 2? That's not what was the graph look like?
Shut up, Dylan. They're about to bang my door down. All right, so listen. Because it's negative. Okay, so that negative is doing like this. It's 1 through 10, and then it's 11 through 29 odd. 1 through 10 is just looking at